we have basically started with sequential circuits, and we have differentiated between what do you mean by sequential circuit and what is a combinational circuit we have seen. And what is the difference between a sequential circuit and a combinational circuit we have seen? And we have started with latches. And in latches, we have seen about SR latch and using NOR gates. We have started our discussion. Let me also share my screen so that we can see. One second. Yeah, I hope my screen is also visible. So basically, we have started with the discussion of um, latches yesterday in our previous session. Where is it? Yeah, we have started with latches, right? And we have discussed about SR latch where we were having R and S in this position, and also we have come up with the table which basically tells us how the latch is going to work. And also we have tried to interchange the positions of this S and R, and also we have seen what kind of characteristic it was giving basically, right? This is what we have discussed in our previous session. And yeah, now in this particular session we will continue our discussion about the latches. So the second latch which we are going to discuss, okay, first of all we need to discuss this SR latch using NAND gates. Has anyone tried this SR latch using NAND gates? So try to solve the assignments. It will be helpful in your preparation. Yeah. So coming to this SR latch using NAND gates, this is how it is going to look like. This is my NAND gate and this is one more NAND gate. And the output of this gate is given to this and the output of this is given to this, right? And here I'm going to give S and here I'm going to give R. This is my present state and its complement is Q and copper. And I'm going to have S, R, Qn and Qn plus 1. And let us have all the combinations 000, 001, 010, 011, 100, 101, 110, and 111. Okay. These are the different combinations which we are going to have. Now let us check it out. What is that we are going to have? So let us also draw the truth table so that you can have the analysis easier. This is 1, this is 1, 1, and 0. Now, let us see. You can see if any one of the input of your NAND gate, if it is equal to 0, obviously you are going to get your output is equal to 1. So please remember that particular property. So S is equal to 0 and R is equal to 0, present state is equal to 0 and its complement if it is equal to 1. So what is that we are going to have? You can see S is equal to 0. One of the input of this NAND gate is equal to 1. Immediately you can write it down as 1 and here also you can write it down as 1. Okay, now this one will be propagated over here and this one will be propagated here. Then also you're going to get one only. One and one. So whenever your S is equal to 0 and R is equal to 1, your present state is equal to 1, your next state is equal to Qn is equal to 1. And Qn complement, Qn plus 1 and its complement are both are equal. But this is not valid. This is an invalid condition, right? So that's the reason I'm going to write down don't care over here. And in this combination also, it is don't care. You can check it out. So whenever your S is equal to 0 and R is equal to 0, whatever may be your present state, your next state is an invalid state. You can see over here, your Qn plus 1 and Qn plus 1 complement are equal, but it should not be equal, right? Any value, its complement should be if it is equal to 1, then the complement should be equal to 0. It should be opposite, but here both are same. That's the reason it is invalid, right? Now, let's say the second combination where your S is equal to 0 and R is equal to 1. Let me erase this. So we have S is equal to 0 and R is equal to 1 and Qn is equal to 0 and Qn complement is equal to 1. For this condition, let us check it out quickly. So S is equal to 0 and R is equal to 1 and Qn is equal to 0. Okay. Now, as I have said you, if one of the input is equal to 0, output will be definitely equal to 1. This will be equal to 1 and this one will be propagated over here. 1, 1 is basically 0. Now, even if you propagate this 0 over here, you're going to get 1 only. Okay. So this is what you're going to have. S is equal to 0 and R is equal to 1. Next state is equal to 1 and its complement is equal to 0. So next state you're going to get it as 1. And if you calculate this also, you're going to get the same thing whenever your S is equal to 0, R is equal to 1, and if your present state is equal to 1, your Qn plus 1 is equal to 1. Okay. Now, so this is the scenario where S is equal to 0 and R is equal to 1. You are going to get your next state is equal to 1. Irrespective of your present state, it might be 0 or it might be 1. You are going to get your next state is equal to 1. Okay. Now let us see the other case where S is equal to 1 and R is equal to 0. So S is equal to 1 and R is equal to 0. Let us see this particular scenario. So in this particular scenario, what is that we are going to have S is equal to 1 and R is equal to 0 and your present state is equal to 0, or present state it might be equal to 1. So what is that we are going to get? Let us see. So S is equal to 1 and R is equal to 0. So this will become 1. So initially, let's say this is equal to 0 and this is 1. So this will become 1 and this 1 will be propagated over here. 1 1 is equal to 0. So 0 0 is also equal to 1 again. So you're going to get your next state to be equal to 0 in these two cases. Whenever your S is equal to 1 and R is equal to 0, irrespective of your present state, it might be 0 or it might be 1, you are going to get your next state is equal to 0. Okay. That is one scenario. And let's see the last scenario where your S is equal to 1 and R is equal to 1. So let's see the last scenario where S is equal to 1 and R is equal to 1. So what is that we are going to get? And let's say your present state is equal to 0. So present state is equal to 0 and its complement is equal to 1, S is equal to 1 and R is equal to 1. Now, now we cannot directly determine the NAND gate output. We need to get one of the input. So here the input, here it is 1 and here it is 0. Now 1 1 is 0 and 0 1 is 1. So you can see whatever the previous state, it was holding that particular state. So it will be 0 and it will be 1. Okay. So you can see it is directly opposite to whatever which we have discussed using the NOR gates. So in the case of your NOR gates, whenever your S is equal to 0, R is equal to 0, it was having the hold condition. But in the case of your NAND based SR latch, you are going to get the reverse one. Whenever your S is equal to 0 and R is equal to 0, you are going to get the invalid condition. This is my invalid condition. Okay. Now, whenever your S is equal to 0 and R is equal to 1, you are getting reset condition, this reset condition. But here you are getting set condition. And this is reset condition, but previously you are getting set condition. And this is in the case of your NOR based SR latch, you are getting invalid, but here you are going to get hold condition. So this is how we are going to work with a SR latch using a NAND gates. Okay. Is it clear? Any doubts or any queries over here? Shall we move forward? Yeah. So in the case of your SR latch using NOR gates, this is the conditions you're going to get whenever your S is equal to 0 and R is equal to 0. Let me calculate it S, R and state. Let me write down state. So in the case of your NOR based SR latch, whenever your S is equal to 0 and R is equal to 0, it's a hold condition which we were getting. And for 0, 1, it was an reset condition we were getting. And for 1, 0, it was set condition. And for 1, 1, you are going to get invalid condition. When I'm working with my NOR based SR latch and the derivation we have derived in a previous session. Okay. But in the case of your NAND based SR latch, the table is flipped. So in the case of your NAND based SR latch, let me draw it over here, S, R and state. So 0, 0, 0, 1, 1, 0, 1, 1. This is invalid and this is set and this is reset and this is hold. So this is nothing but my NAND based SR latch. Okay. Yeah. Now let us see about the other latch which we are going to have is D latch. So D latch is also known as data latch. Whatever the input you are going to give, that is being reflected at the output. That is nothing but my D latch. Okay, so yeah, let us discuss that particular D latch which we are going to have. So before D latch, let's discuss JK latch. It will be more easier discussing JK latch because Just now we have seen in the case of my SR latch, I'm going to get one invalid condition. Whenever in the case of my NOR based SR latch, I was getting if my S is equal to 1 and R is equal to 1, it was invalid. And in the case of my NAND based SR latch, whenever my S is equal to 0 and R is equal to 0, it was invalid, right? Now, in the case of my JK latch, let us see what is that we are going to get. Now, in JK latch, basically removes the invalid condition which we have encountered in the case of my SR latch. Okay, how we are going to encounter it? Let us see. So first of all, let's see the NOR based JK latch. So the NOR based JK latch which we are going to build is using the SR latch only. So I'm going to have this NOR gates, and this NOR gates, I'm going to have one AND gate over here and one more AND gate over here. Okay. Now, this output is basically fed to the input of this AND gate, and this output is basically fed to the input of this AND gate. Okay. And over here, I'm going to have K, and here I'm going to have J. Okay. This is nothing but my JK latch. Now, how this is going to work, let us try to understand. Now, you can see this particular circuit which we are having over here. This is nothing but my RS latch only. This is R, and this is S, and this is my present state, and this is my its complement, Qn complement. Okay. Now, so let me tabulate it quickly. JK, Qn, and Qn plus 1. I'm going to have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So let us see what is that we are going to get in this particular things. Now, since we have already done the discussion of this particular RS latch and we have evaluated everything in each clear detail, now there is no need to evaluate them again and again. Just, okay, how to do it? Let me show you. So let's say J is equal to 0 and K is equal to 0. So you can take K is equal to 0 and J is equal to 0 and present state is equal to 0 and its complement is equal to 1. This is what we are going to get. Now, here one of the input of this is 1 and here we are going to get 0. So you can see AND gate output will be equal to 0. That means R is equal to 0 and S is equal to 0. Now, from the previous discussions, we already know that for an SR latch, if we are going to give R is equal to 0 and S is equal to 0, obviously you are going to be in the hold condition. So that's the reason you are going to simply write down Qn or it is equal to 0. Okay. So there is no need to again evaluate it. Here it is 1 and here it is equal to 0. So the output will be 0. No need to evaluate it again because we have already done that particular evaluation in the previous session. So we already know that the if R is equal to 0 and S is equal to 0, what is going to happen? We already know. So no need to evaluate it again. Okay. Now, so let's see the next condition where 0, 0, 1. So here also, since K is equal to 0 and J is equal to 0, one of the input of AND gate is equal to 0. You don't need to wait for the other input. So if one of the input is of the AND gate is equal to 0, obviously the output will be equal to 0. So in this condition, whenever your Qn is equal to 1, since J is equal to 0 and K is equal to 0, again R will be 0 and S will be 0. So it's in hold condition only. So it will be equal to Qn or it is nothing but it is equal to 1. Okay. So in the case of your SR latch and in the case of your JK latch, both the cases you are going to get the hold condition. Okay. Now let's see the next condition where J is equal to 0 and K is equal to 1. So let me erase this quickly. So we have J is equal to 0 and K is equal to 1. And let's say Qn is equal to 0 and its complement is equal to 1. So here we are going to get 0 and here we are going to get 1. So the output of this gate is equal to 0 and the output of this gate is also equal to 0. So S is equal to 0, R is equal to 0. We already know it's a hold condition. So Qn will be 0 and Qn complement will be equal to 1. You can see whenever your J is equal to 0 and K is equal to 1, Qn is 0. If your present state is 0, next state is equal to 0 and its complement is equal to 1. Okay, this is equal to 0. Now let me quickly change this value to 1. Okay. Now you have one of the input of this AND gate is equal to 1 and this is equal to 0. This AND gate input is equal to 0. So what is going to happen? This R will be equal to 1 and this will be equal to 0. So S is equal to 0, R is equal to 1. We know already it's a reset condition. So again, what is happening? Qn is becoming 0. Okay, and its complement is equal to 1. So whenever your j is equal to 0 and k is equal to 1, whatever may be your present state, your next state will be equal to 0. So this is nothing but my reset condition. Whenever your j is equal to 0 and k is equal to 1, it's a reset condition. And if you don't know about this particular latches, this working, I recommend you to once please practice them. These are the very fundamental things which you should know. Okay, you should know without performing this kind of analysis. You should know this working of this latches. That is very, very important. Okay, and when we are doing problems, also this will be very, very useful when we are doing them. Okay, yes. Now let's see the next condition. Obviously, we are going to do so many problems related to this particular latches and flip flops also. So these are the fundamentals that should be discussed. Yes. Now j is equal to 1 and k is equal to 0, which we are going to have. Now, obviously, the AND gate output will be equal to 0 only. And let's say Qn is equal to 0 and Qn complement is equal to 1. So here I'm going to have 1. So AND gate output is equal to 1, S is equal to 1. S is equal to 1 and R is equal to 0. We already know it's a set condition. So this will become 1 and this will become 0. Okay. So what is going to happen if your Qn is equal to 0? Its next state is equal to 1. Now, let's say Qn is equal to 1. In this case, let's say this is equal to 1. If it is 1 also, since k is equal to 0, AND gate output will be equal to 0, R is equal to 0. And this is equal to 0. So this is equal to 0. So S will also be equal to 0. So S is equal to 0, R is equal to 0. It's a hold condition. So whatever the Qn, it is equal to 1, right? So it will be staying to 1 only and Qn complement will be equal to 0 only. So in this scenario also, you are going to get 1. So this is nothing but my set condition. Okay. This is hold, reset, and set. Now, so up to here, the same characteristics we were having in the case of my SR latch and in the case of my JK latch also, I'm going to have the same conditions, right? Now, let us see the last condition where your J is equal to 1 and K is equal to 1 and Qn is equal to 0. Okay. So let me erase the previous ones quickly. I have J is equal to 1 and K is equal to 1. And let's say present state is equal to 0. So my present state is equal to 0 and its complement is equal to 1, k is equal to 1 and j is equal to 1. So this 0 will be propagated over here, this 1 will be propagated over here. So s will be equal to 1 and r will be equal to 0. So s is equal to 1, r is equal to 0. It's a set condition, so this will be equal to 1 and this will be equal to 0. Okay. So you can see if your present state is equal to 0, your next state is equal to 1. Okay. Now let's see this condition. So let's say your present state is equal to 1, you're going to get 1 over here. That means reset is equal to 1 and your complement is equal to 0. This is equal to 0. That means S is equal to 0. That means it's a reset state. So you're going to get R, your next state is equal to 0 and its complement is equal to 1. That means here you are going to get 0. You can see whatever the present state that is getting toggled. So this is nothing but my toggle state. So the JK latch is basically trying to remove the invalid condition which you are getting in the case of your SR latch. SR latch, whenever your S is equal to 1 and R is equal to 1, you are getting the invalid state. But in the case of your JK latch, you are basically trying to remove that particular invalid condition. Okay. Yes. So any doubts or any queries in this? Shall we move forward? Great. Yeah. Now, this is using NOR gates, right? Let me give you one more circuit. So please try this assignment and let me know. Tabulate this particular table by providing the corresponding inputs, like whichever the analysis which I've done, right? So like this only, please do the analysis for the given circuit and please let me know. So if you practice this assignments, the problems will be very easier. When you are doing problems, you might think, what is that? It's very easier. But definitely in pressure, the simple problems will be very difficult and we will be doing so many mistakes. So that's the reason digital design needs so much of practice. So yeah. So this is my NAND gate and this is NAND gate and gate, and the output of this is given to this feedback, and this is basically given to this, right? And here I'm going to have J and here I'm going to have K. So same kind of analysis, please try to do for this particular circuit. This is JK latch using NAND gates and tabulate it. Okay, so let's see what is that we are going to get. Okay, yes. Now, let's see one more latch, which is D latch. Okay. Okay. So before that, let us see D latch using NOR gates. Now, how to build it? So first of all, I'm going to build the JK latch. So you can first build the JK latch using NOR gates. So how to build a JK latch? First build the SR latch. That's it. This is how you can remember it. Now keep the AND gates. Give one more AND gate, and this is K, and this is J. And you have a feedback over here, right? Now, T latch is basically a toggle latch. First of all, let me give the characteristic table. So from the characteristic table, we can easily predict what can be the circuit. Okay. So let me give you the table first. So T, Qn and Qn plus 1. So T is equal to 0, Qn is equal to 0. It will be in hold condition. Whenever your T is equal to 0, it will be in the hold condition only. But whenever your T is equal to 1, whatever your present state may be, it will be complemented or it will be toggled. Okay. So this is how your T latch is going to work. Whenever your T is equal to 1, your present state will be toggled. If your present state is equal to 0, your next state will be equal to 1. If your present state is equal to 1, your next state will be equal to 0. So this is how your T latch is going to work. So by seeing this table, can anyone tell me what kind of modification which we can to this particular circuit so that it can work as a T latch? Is the question. Can anyone answer? What kind of modification which we can do to this particular circuit so that this particular circuit can act as a T latch? Think about it and answer. So T latch toggling is happening over here. So what kind of modification can we do so that we can achieve this kind of toggling? Okay, fine. So in the case of your JK latch, if you have remembered, whenever your J is equal to 1 and K is equal to 1, you are getting the toggle condition. So same property I can use it over here. What I can do is I can connect this J and K, short it and make it as T. So whenever your T is equal to 0, J will be equal to 0 and K will be equal to 0. It will be in hold condition. But if your T is equal to 1, then this 2 will be equal to 1 and it will enter into the toggle condition. That's it. So this is how you're going to build a T latch. And your assignment is to build a T latch using NAND gates. This is your small task to do. Okay. So that's about this particular session. And we are left with D latch. And after discussing D latch, we will see why we are not preferring this latches and what is the issue with this particular latches and how we are going to overcome. And next, we are going to discuss how we are going to develop a flip flop and all that we are going to discuss. Okay. Yes. So that's all about this particular session. If you have any doubts or any other queries you wanted to discuss, you can stay and discuss with me, or else we can wrap up this session. Okay. Thank you.